So here we go. So here they are going for a huge long walk. The use of a cart. They returned 42.8 samples. So immediately twice the amount of material that Apollo 11 brought back. That's where they walked. So they walked an incline of 100 metres. Quite a few kilometres. That's a lot of walking in those suits under those conditions. So Apollo 15 in July 1971. David Scott, so he was the guy at Apollo 8 with Neil Armstrong, not Neil Young. And Jim Irwin was the lunar module pilot, and Al Warden, command module pilot. Their objective, never mind going to the sort of the more flat, sort of safer bits, they thought, why don't we go into the highlands, the older part of the moon? We're more advanced now, let's give it a go, and that's indeed where they went. They stayed 3 days on the moon. They did 3 moonwalks. Look at this, getting up to 18.5 hours of moonwalks compared with 2.5 hours for Apollo 11, which the media still can't get over. They're still flapping about 2.5 hours. Woohoo! But these guys are 18 hours.
How much of that moonwalk would include driving the buggy?
Quite a bit, and these guys were the first to...
So it wasn't all walking, it's 18 hours, so it was driving.
Oh yeah, look, and just digging and drilling and doing bits and pieces and stuff, absolutely. Look at the 77 kilograms of samples coming back now. You can see the antes just going up and up and up with each mission.
To do this, Chris, you had to have more rocket fuel to lift off the moon, more for the descent stage. Yep. Saturn V was also souped up to actually hoist the whole lot into orbit.
And that illustrates the whole point. Each mission, the hardware even was just kept building on the previous experience. It was like America's Cup. You know, they don't just go out there with one boat and go. They're developing it all along. It's the same principle here throughout the whole program. They're constantly developing the Saturn V rocket, or developing the lunar module. And here these guys landed right up in here, way up in the Apeninne highlands. So, here is the lunar module sitting precariously on a 10-degree tilt. That was off some concern. Are we going to be safe launching? And I put this here because it was Dave Scott who won the competition with the fastest reaction. When that contact light hit, he slammed the button, shut the engines off, and he landed the craft with a 10-degree tilt. They realised there was nothing they could do about it, so we thought, well, let's just get on and do what we're here to do. And it turned out it was all okay. They were sort of a bit nervous about all of that. It appeared stable at the time for them to be in it. Okay, they were the first to use the Lunar Rover, as Warwick alludes to. So it was Apollos 15, 16 and 17, this little buggy here, electric motors on all 4 wheels, so it couldn't get stuck or anywhere. Top speed of 18 kilometres an hour, which was done by Gene Cernan on Apollo 17, and a range of 36 kilometres, but they never went that far. The range, how far they took it, was always constrained by the astronaut oxygen levels. There's no point in going for a big 2-hour trek in this, and if it breaks down, you've got a 4-hour walk back to the lunar module, and you've only got 3.5 hours of oxygen in your suit. So how far they went was always constrained by the amount of oxygen the astronauts had. So they did a total of 24 kilometres, 28 kilometres rather, which of course allowed a very productive field geology to be done. That's the wheels, made of aluminium and zinc, with some titanium chevron treads like a tractor. Now, Apollo 15, he talked Apollo 15 would not be complete without this cool little video clip. So they were very much into their science and experiments, and Dave Scott wanted to prove a theory that Galileo showed, that under a gravitational force, the acceleration of 2 objects is exactly the same. It doesn't matter how heavy they are, what, you get a big marble, or a little marble rather, and a big, huge, big whatever, you drop them and they hit the ground at the same time. He thought, why don't we try it with a feather and something heavy on the moon where there's no atmosphere to interfere, like a feather, just that. So he does this feather and hammer experiment on the surface of the moon. only one place in the entire where you can do that experiment. Yeah, and that's Apeninne, the lunar module pilot Apollo 12. You've got the photos. He rather got him to do painting. He did a painting of that scene. It was quite cool. So Apollo 16 launched in April 1972. These are John Young. That was his second time to the moon. He was the command module pilot for Apollo 10 that did the full dress rehearsal. He was now the commander. Charlie Duke was the lunar module pilot. He was 36, as we talked about, the youngest man to walk on the moon. And Ken Mackington, who was the command module pilot. So their objective was also to go up to the Highlands, the Descartes Highland area, which they thought the formations up in here might have been volcanic in origin. They did 3 moonwalks, total of almost 20 and a half hours of moonwalking, compared with Apollo 11's 2.5. As opposed to Apollo 11's 21 kgs, these guys brought 94.5 kilograms of rocks back. Huge difference. So this is then by called a Plum crater, once again. Lovely spot. It's nature's big borehole essentially. It spits all the internal contents out, so it makes a good place to go and get rocks. They found that reefier rocks are rocks that are sort of almost like multiple types of rocks all jammed together. And they found that when they got those rocks back to Earth, they were probably caused by multiple impacts rather than volcanic activity. Also famous to Apollo 16 was house rock. That rock is the size of a house. As you can see, that's one of the astronauts there next to it. There's the lunar module. That's the size of that rock. It's being biffed out of the crater. That's John Young jumping for joy. And there's a UV spectrograph. That's what gets my attention in this picture here. Look at the UV spectrograph. So what is the importance of the UV spectrograph? Why put one on the moon?
Because you've got an atmosphere filtering out the ultraviolet.
Yeah, absolutely, because there's no atmosphere. Here you go, Andrew.
Why would I shade then?
I think that's you can still look in the sun while you're sitting in the shade. And also you don't want to blow out all your sensitive instruments. But the point being is, yep, this was the first sort of scientific instrument such as a spectrograph taken to observe the sun. So they essentially studied the sun in UV ultraviolet light because you could, there was no atmosphere. Yeah, Keith?
Is that the armbands that they put on to identify the command?
Yeah, absolutely. When you look at Apollo 11 and 12 and you think, who's who here? They got like a holiday snapshots taken back. Oh, who was that? Who was that? They couldn't tell. So Apollo 14 onwards, the commander has the big red stripes. Yep, so he can so they know which one's the commander, of course without the red stripes, doesn't it? Yep, so well spotted there, Keith, yeah. And that was the sole purpose. So later on, looking at the photographs, they could tell who was still on the moon.
Notice all the dust clinging to the suit.
Yep, the dust, it was a real problem, the dust clinging to their suits. It clung to them, to their suits. It was very abrasive. They didn't want to get it into their instruments. They had no idea how it would behave in their lungs. Was it going to be like asbestos? Who knew? They said it smelt like spent gunpowder. And so, when the guys from the moon went up to the command module, they went back up again to go home, they didn't want all that dust going into their sensitive instruments in the command module. So what they did, they set up a very low gradient of air pressure, just going from the command module into the lunar module. So any bits of dust and grain, of course they had to clean themselves off. They had brushes, they cleaned themselves off when they left the moon, and they brushed themselves off before they went to the command module. But they had just a low sort of air gradient pressure.
And Chris, the flag that's flying there, that's fluttering, is much wind then, or?
No wind. No, it's,
But the flags look.
I know what you're saying. People often comment on that. And how much alluding to, they'll go, oh, how come the flag's flying, and how come you see it, some of it actually flittering like that?
Yeah.
And of course, it's got wires all through it to make it look. They're not going to put a flag up there and let it look flaccid. So they did that on purpose. And the reason it flicks backwards and forwards when you see an asteroid near it, it's electrostatic charges of this suit going past it. And because there's no atmosphere to buffer that, it does. It just flitters and keeps flittering until it eventually settles down with friction. So the conspiracy guys love to use that, what you're alluding to, love to use that argument. And I tell them that it actually proves that they're in a vacuum. You didn't expect them to go up there with a flash of fact. Of course they're going to stretch it out. And the other thing you say to them, you say, well, just if that was going to be on Earth, and you had enough wind to create a flag flattering to that degree, wouldn't you expect to see just dust everywhere? You wouldn't be able to see that scene from dust flying around. But.
They also didn't fully extend the
Yes.
right at the top was telescopic, and they didn't fully extend it so it looked more ruffled.
Yeah, they want it to look real. That's why they did it. They wanted it to look real. So Apollo 17, final mission. Gene Cernan, the commander, who just passed away last year. Ron Evans, command module pilot. Jack Schmitt was the lunar module pilot. He was the first geologist, the first scientist, the first non-astronaut to go to the moon. They realised this was the last mission. Let's get a geologist, a proper professional geologist up there. To the astronauts' dismay, but he proved himself. He was good. He did good work. So they also ended up in some highlands. There, they did 3 moonwalks. Now you're talking 22.5 hours. They travelled the full 36 kilometres on the rover. Look at this, 110.5. A total of 382 kilograms was brought back from the moon, and almost a third of it was from this last mission. So you can see the ante's just gone up from a 2.5-hour moonwalk to 22.5-hour moonwalk, from 21 kilograms of rock to 110 kilograms of rock. Just keep going up and up.
Was it always the same rover?
No, different rover every time, brand new rover. They left the old rover there. Yeah, absolutely. Yeah, what?
Was it the guy Smith who was caught singing on the moon or something?
That was Jack Schmitt. He was singing on the moon.
Yeah.
To Gene Cernan. And with your lunar, to ask you a question about the lunar rovers too, everything is about weight, getting back to Earth again. So you don't want they just leave everything there. They just go back, in the ascent stage of the lunar module. They throw everything that they do not want excess. They biff it out the door before they leave. Waste and the cameras and stuff. They just biff it out onto the surface. So it's all that way. You leave anything you don't need to take back to Earth. You leave it there on the Earth, on the moon rover. Yep. Yeah.
So the vehicles from Apollo 15 onwards, were they foldable because they're quite big?
Yeah, so from Apollo 15, 16, 17 with the lunar module, it's quite a big sort of bulky thing, how it was all nicely folded up against the side of the lunar module, and they pulled on a lever and just concertinaed it back out again, and then it all flopped open into place. Yeah, much like an ironing board sort of type of setup. See, I do my ironing. So this was the famous orange soil. They found some orange soil on the moon. In the end, they concluded it was rich in titanium, iron oxide, and zinc. It was probably volcanic in origin. Probably some almost glass-like. Volcanics throw stuff up into the air and it pulls in the air like glass. This is a lovely picture here of Gene Cernan after his last spacewalk. Look how grubby he is. God, I hope there's mud. I never saw him like that. But you see, he's pretty grubby. And it just got all over them. So there was nothing glamorous about it all. And that's where I put it there. We've told you that story about the command module. Set up that nice little gradient of air. So the human factor. So this is a famous picture of Buzz Aldrin going down the ladder. Neil took this picture. What's going on here? He's taking a pee. He was poised on the end of the ladder. That took them some time, as Bill alluded to, had to help each other into their suits. That took some time, all the excitement of landing on the moon. He suddenly realised he had a full bladder. Neil was just carefully phoning him out, said, look, just hold yourself there for a while and get some pictures taken. And we want to know, where proportions, what's going on. They don't just climb down the ladder, they're constantly analysing things. And Buzz Aldrin quite happily owns up. He says, yep, I was taking a pee there. I was just poised there for 5 minutes. I needed to go. There was nothing else for me to do. So I went. I was the first man to pee on the moon. He could be the first man to walk on the moon, so he better be nice or something. So that's Buzz Aldrin, quite open, so he was having a pee. That's a photograph there of Alan B. Shepherd with his scoop handle that he attached the iron to for his golf. So it's just some of the human side of going to the moon. This is a nice little story. That's Charlie Duke here, and this is the orange hair story. So Jim Irwin, the lunar module pilot on Apollo 15, they noticed that he was throwing some cardiac arrhythmias called atrial fibrillation. They monitored their heart the whole time. They never told him at the time, but his heart was doing funny arrhythmias. And they figured it was probably because he was sweating profusely in his suit. He was sweating too much, he was losing too much potassium, and his potassium levels got quite low. And the heart does not like low potassium levels. So he started throwing some atrial fibrillation on his heart monitor. So to prevent that for Apollo 16, they gave them big bags of orange juice in their helmets. It was rich in potassium. And the bag sat there, had a little tube, and they could quietly suck on it to keep the potassium levels up. And when they leave the command module and undock and go to the moon, they have to be fully kitted up in case there's a breach in the oxygen level or whatever, so they don't take any risks. And normally it's only about a 20-minute trip down to the moon. But it so happened this time that the command module pilot, Apeninne, noted, hey look, I've got a problem with my computers here. So that took them about 6 hours to fix those computer problems. In the meantime, the mission rules were, that command module, it's your journey home. If that's got a problem, you do not go and land until we've got this problem sorted out. So unexpectedly, Charlie Duke and John Young spent about 6 hours in lunar orbit. And of course, the orange juice just spilled out of their suits everywhere and just totally dyed his hair. So when he took his helmet off and he got to the moon, his hair was just totally dyed orange. So he called himself the first punk rocker on the moon. So that's a little sort of human story there. And Charlie Duke left this picture of his family, and he left that picture on the surface of the moon. So we're still sitting there now. But of course, with the ultraviolet light, that would have all been bleached now. But he threw that on the moon, one of the last things he did before he left the moon. People often ask what are the flags like. The flags may still be standing. Apollo 11 blew over as they blasted off. But even the flags will be all bleached. All the colours will be bleached out of them because of the harsh UV lights. But he left a photo of his family there for eternity. So a little bit about the science on the moon. So they did a lot of field geology, as was alluded to before. But a lot of surface experiments were set up on the moon. In particular, seismometer, measuring if there's any moonquakes, magnometer, which sees the magnetic fields and so on the moon, heat flow detectors, is there any heat coming out from the internal moon, laser ranging, which determines they can fire a laser from the Earth to the moon, back again, and they can accurately measure the distance to the moon and how it's changing, about 3.2 centimetres per year. Instruments to measure the composition of the atmosphere, and of course you've seen this one here, the solar wind experiment, just to see what the solar wind is made of. They put that experiment out, capture all the particles, and fold it up and take it home again. So you're probably wondering what were some of the results of those. So the seismometer, that's it there, that showed that the moon is geologically inactive, but there are moonquakes that do happen from tidal forces. The moon's been stretched and pulled as it orbits the Earth, and that creates what they call little moonquakes. And moonquakes could go on for about 20 minutes or so, because it's a very dry environment and there's no moisture in the material, so to dampen things down. An earthquake on Earth gets dampened down pretty quickly because of the moisture in the soil. But it's very dry, so it sort of tends to reverberate for a lot longer. The magnetometer showed there was no sort of global magnetic field. In other words, there's no magnetic field surrounding the whole moon, but there are little regions of magnetisation, magnetic field lines, the local ones on the moon, that vary between location and time. You might think, well, that's a bit strange. But it all came about to there's different concentrations of different minerals and so on the moon that give rise to different magnetic fields. And as for time, the moon's going around the Earth, its turns go around the sun. It's very vulnerable to magnetic field and influence from the Earth and the sun. So the magnetic fields change on the moon with time as well. There. The heat flow experiment, they drill that into about 2.3 metres, and they measure if there's any heat flow from the interior, and there was very, very minimal, if any, heat flow at all, suggesting there's really no geological activity going on in the moon. Laser ranging, as I mentioned, as the moon appears to be receding, and there's a good reason for that. It has to do with tidal forces and so on, but it is receding at 3.2 centimetres per year from Earth. And that, in other words, in another 620 million years, we will not be able to have any more total solar eclipses. It's only a window, it's just a coincidental window we're living in. About 1 billion years, but about another 620 million years to go before that will be, the moon will be too small for us to get a total eclipse, get an annular eclipse. Hope to see Atmospheric composition, the Moon has a very tenuous, very thin atmosphere, bit of sodium, potassium, helium and argon, probably from charged particles and gamma rays, cosmic rays, coming down from the Sun, striking the surface and just sort of and atoms just flying up from the surface. The solar wind experiment showed that 95% of the solar wind is protons and electrons in equal numbers, and that certainly makes sense what's pouring out of the Sun. It's just electrons and protons. So, how about the 382 kilograms of rocks and soils, which remember Apollo 11 brought back 21 kilograms, Apollo 17 brought back 110 kilograms to show you how the angle was just getting pumped up. Extremely old compared to the Earth rocks, which of course have been subjected to all the erosive forces. The Highland crust samples, they carbon dated them at 4.6 billion years old, so which ties in with the age of the solar system. The Mare, there's these deep, sort of these dark volcanic plains, about 3.2 billion years ago. So clearly the crust formed first, and then what happened is these mares were filled in from lava. These big valleys got filled in. Most of the rock was igneous rock, which is rather all of it, I should say, rather, which is molten lava. There's no sedimentary rock on the Moon. It's all from molten lava that's solidified, and that immediately infers the outer proportion of the Moon was all once molten. So that's the evidence for that. Furthermore, most rocks are mainly, there's mainly three different types, what they call the basalt, which is full of titanium and magnesium, which makes up this dark sort of maria here, a dark colour to it, and that's all sort of heavier metals that have sunk down initially and then been brought up to the surface with impacts, and it looks very dark. The lots of breccia, that sort of breccia type rocks here, which we've talked about from impacts, meaning they're consistent with the Moon's being subjected to a lot of impacts in the past. And orthosite, mouthful, and orthosite, that's all that white material you see in the highlands. There's a lot of aluminium and calcium that forms the white highlands. And the red, that's very light, sort of light chemicals that have all sort of floated when the Moon rather was molten. All your heavy magnesium and your titanium sinks down, and that's just the darker material, which leaves your lighter material to form this sort of light-coloured highlands. Very low in volatiles, your sodium, potassium, and water, and so on, which is all really supports the giant impact hypothesis of how the Moon formed. In other words, when the Earth was about 500 million years old, a large object the size of Mars collided with it, the material all got flung out into Earth orbit, recoalesced and formed the Moon. And that all this ties in with it. I'm not saying it's right, but it's the model that seems to best fit. So what do the landing sites look like today? Here we are. Once again, here we are. The Americans and the Japanese both have lunar reconnaissance high definition cameras going around the Moon in orbit, and the purposes of trying to get a nice 3D mapping of the entire surface of the Moon for purposes of future planning, where they're going to put bases and what exploration they're going to do. And of course you just can't help but see all the landing sites. Cameras, there's the lunar module. So this is Apollo 11, Apollo 12, that's Surveyor 3 where they landed. And we saw the photograph looking back towards the lunar module. It's Apollo 14, you can see the track that all went with the little cart thing. That's the Apollo 15, there's the descent stage, there's the Lunar Rover that they left behind. So there. That's the Apollo experimental system that they leave. You can see all their nice little tracks.
All those black arrows, or Chris?
What's that, sorry?
The previous photograph, all those black arrows.
Oh, tracks, I think. They're pointing at tracks. The Lunar Rover tracks, I think.
Well, those are tracks, or the other ones?
Tracks and footprints. Because there was a lot of activity. This is reasonably close.
Okay.
Good question, yeah, good question. This is reasonably close. The Apollo Lunar Surface Experimental program, that was all carried out there. So this is a small area. You can see the size of the lunar module. So this is a relatively small area, and here's the tracks of the Lunar Rover heading on out. This was all just footprints and stuff. Yeah, there's your thing, 50 metres there. So let's go 100 metres out.
I think the darker tracks are the footprints because the rover didn't really make a bigger, didn't disturb the dust.
Yeah. 16. It's Apollo 17, descent stage. And it was Apollo 17, that was the Lunar Rover. There it is there. They actually filmed the launch. So, tonight I've shown you there are 28 missions into space that prepared the way for the success of Apollo 11. Despite the media saying, yay, 50 years since the moon landing. 28 missions prepared the way for the success of Apollo 11. From 68 to 72, 24 men travelled to the moon. 12 of whom walked on the surface. Each successive mission, technically and scientifically, was more advanced, far more exciting. A total of 382 kilograms of rocks were returned to Earth for geological study. They're still studying them. They knew in advance that, hey, technology in the laboratory is going to get better and better. So they quite wisely withheld a lot of rock. And they've just recently opened up some more packets and samples of rock, knowing that, we were talking another 50 years down the line for the ability to do mass spectroscopy and so on and analyse the rock. The rocks go all around the world. And as we mentioned, there was many surface experiments to set up to determine the moon's properties. So we learned a lot from it. So I hope you've enjoyed an overview of the Apollo moon landings to impart the idea there was much more to the moon landings than Apollo 11. Thank you. Any questions? That's by son, by the way, Boston.
I thought they would be very careful not to contaminate outer space in any way at all. So how come an astronaut's allowed to wee on the moon?
Oh, in his suit.
Oh, in his suit.
In his suit.
Oh, I see.
Yeah.
Warm toast.
Yeah. And he would have had a proper bag and all that sort of stuff. There is a story. Now, who was it? It was one of the Mercury guys. Was B. Shepherd or something? He was sitting in the launch. Yeah, and they just went, look, you're 15 minutes in space. For God's sake, sit in your rocket, sit still until we're all ready. And you have a big drink of orange juice, cup of coffee beforehand. And he sat up there, of course, the flight got put off, and he sat up there for hours. And he said, oh, I've got to go to the toilet. And they said, well, we can't pull you down. What's it to go? And it was the flight surgeon, and then he said, look, just pee in your pants. But once again, there was a bit of risk. All electrical circuits going on and stuff. They just had no choices. Look, I've got to go. So, yeah, there's nothing glamorous about it all. And yeah, so that was a good question. Any other questions? Yeah, yes.
Did they have any close shaves, like nearly knocking it off, or any major other than 13?
Yes.
Obviously?
Yeah, there's a lot of little incidences. Well, not necessarily little either. The Apollo 12, the lightning strikes. It was Apollo 14, I think it was Apollo 14. Well, Apollo 14, two things. One is I actually put the models here too, that's why I wrote that up, and you can have a closer look. The command module, so here's the lunar module, and it's all stacked up. They're heading off to the moon. The command module pulls out, turns around, and goes in and docks with the lunar module, pulls it out of its casing, it turns around, and they head off to the moon like that. There's latches, hard and soft latches they've got to do to latch on. In Apollo 14, the latches just were not clunking tight. And it was touch and go. They thought, they had about 5 or 6 goes. And it just was not, they were just ramming it, and nothing was working. It was only, they said, look, one will go, otherwise you just come home. Here they are on the way to the moon, you've got to come home, guys. You need to be latched up. And it was just the last one. Whatever happened, just bang the latches, they had their hard docking, and they saved it. That almost aborted the mission. The other one is when the lunar module came into land, they got landing radar. And the radar initially is pointing upwards, but as they tilt it over, it starts pointing downwards. And there is a mission rule, you can't land on the surface of the moon, particularly amongst all the mountains and stuff, if your radar landing's not working. And the landing radar was pointing upwards, they kept flicking it down, and it just would not budge to move it downwards. Once again, just out of the blue, the thing doesn't time, they just rebooted and tried again, and it swung round and to face the surface, and they were able to. And that was Alan D. Shepherd as the commander, and I saw him being interviewed a few years later, and they said, you were so close to the moon, you knew this was your only one shot. If the landing radar hadn't have locked in, would you have still proceeded? You would have been a court martial or something afterwards, or would you just gone in for landing? And he looked out the window and smiled and looked back at the camera and says, "We'll never know, will we?" So,
There was Apollo 11.
Circuit breaker.
There was a button that got broken off
yes,
by Neil Armstrong when they were getting their space walk suits on.
yes.
They didn't realise he'd done it until they came back. And he actually managed to fix it with his pen.
Yep.
And if he hadn't managed to do that, there was doubt as to whether they were going to be able to
Yep.
take
It
off.
was a crucial circuit
Yeah,
breaker
it
for
was
the ascent
crucial,
stage.
yeah,
It was
it
very
was
crucial.
yeah.
Yep, just the backpack. I put the backpack and just
Yeah,
swap the back
yeah.
switch off. Yep. Apollo 11, of course, coming into land, the 1201, 1209 alarms that were going off. They almost aborted because of that. They didn't understand the alarms. There was a young guy, Steve Bales, a young computer guy in mission control, who thought, "Oh, I know what that is. It just means the computer's overloaded. Everything's still going well. Carry on." He got a medal for that. Carry on.
The computer's really interesting. Actually, there's a really good series on YouTube, a YouTuber called Curious Mark, and they just 20-something episodes of this, and they just got an Apollo guidance computer working again. So a team of people, and they've got a test Apollo guidance computer, and they fixed some of the modules on it. They had to drill into some of them and rewire them, and rewire them. It's a really good series. If you're interested in old computers, there's also a documentary, a contemporary documentary about it's called A Computer for the Moon or something. If you search for it on YouTube. And it talks about how they made the Apollo guidance computer, because the computer memory was weaved by, so it was all made of little ferrite rings, and it was woven in essentially like a weaving loom, computer-guided weaving loom to wire up these ferrite cords. So the guidance computer was really quite fascinating.
There's also, of course, on the Apollo 11 final approach, Armstrong had to overfly the original intended landing zone. It was quite touch and go as to whether there was enough fuel.
Yeah, almost
Right.
About 30 seconds of fuel left at the descent stage. Yeah, when he landed.
18.
10.
18.
18.
Yeah, I'm listening to the really excellent BBC podcast series called 13 Minutes to the Moon. And they've just landed on the moon. And the guy who was the fuel guy had a stopwatch that started at 120 seconds, because that was the low fuel level indicator. And he basically timed and had to manually integrate when he was, he had 120 seconds of hover thrust. So if he was using more than that, he had to sort of say, okay, that's less time, and if he was using less, it was a bit more time. So he was manually integrating the amount of fuel, and when they landed and shut the rockets off, it had 18 seconds left on it.
18 seconds.
And the anecdote he shared was, he looked at that stopwatch afterwards, it had all these markers on for times and stuff, and he thought, I'm going to encase that in plastic and keep that forever. And he put it in his office desk, and he thought, no, look, I'm going to take that home. And he took it home and put it in a handkerchief in his drawer, and he went back and looked at it a little while later, and it said 24 seconds. And he thought, hang on, I'm pretty sure that was 18 seconds. Came back at another time, and it was like a different time again. And it turned out that his daughters were cheerleaders, and they were timing their routines. And so he ended up resetting it to 18 seconds and giving it to the Smithsonian. But it's an excellent series on the BBC. It's really BBC World Service. And the other thing, because I was just going to say, I did a little Google check. There were no Apollo 2 and 3 missions.
You checked?
Yeah. And Apollo 1 was named posthumously. So that, all those early missions were called Apollo Saturn, and Apollo Saturn 3 was Apollo 1, and so 4 was the next Apollo Saturn mission. So that became the next mission after what was called Apollo 1.
Apollo 1.
Apollo
Right,
4.
thank you for that.
Yeah.
They had all those sort of testing and Saturn.
Testing
They
the rocket.
had pogo problems with it.
Yeah.
The rocket was jumping up and down doing all sorts of stuff. They're pretty heroes in flights. Yeah.
And there's about 3 minutes to go to Indian rocket launch.
Right.
3 minutes 40. When I go to YouTube, it's streaming live.
I think we'll put just 2 points. People ask what does the W stand for? His full name is Boston Winston O'Boogie Benton. That's his full name. When he goes to the vet, it's all wrapped around the side of the little bottle that he gets. And the other thing I wanted to mention, yes, you know, this is August 1st. This is the introduction for astronomy for August. Serena's doing the movie Night in the Shadow of the Moon. That is an awesome documentary. And then the first Monday of September, for the introduction to astronomy, my good colleague, Swinburne University colleague here, It'll be my pleasure, it'll be your pleasure to hear Jonathan do a fantastic talk on astrobiology and the sort of theme, I think, it's around Titan. There's been a lot of exploration of Titan. That's one of Jonathan's specialties, so he'll be up. He's from the Hamilton Astronomical Society, so he's come up tonight, tonight's meeting, and he'll be up to give the talk for September, so looking forward to that, Jonathan. Thank you. Yep. Otherwise, we're all good. Go home safely, everyone, and most of all, have fun.